Okay, on that assignment sheet, we are going to do things a little differently than what's listed on the assignment sheet. My reasoning being the following: we had very few people in attendance on Tuesday before we went to break. Many of you were on the field trip or just gone. And I got to about maybe 7 minutes of the topic for the people who were here. So I am going to do a second day of what we did on the Tuesday before break. So a lot of things are going to get moved around now. So Friday, December 1st will be Monday, December 4th. All right, Monday, December 4th. Thursday will become Friday, December 1st. Okay, so Thursday is going to become Friday. Wednesday is staying where it is. We are still having the quiz on Wednesday, which I'll go over in a second. Tuesday will become Thursday now. Tuesday becomes Thursday, and Monday becomes Tuesday. All right, so your homework for tonight, if you haven't done so already, or did a really, really poor job and just went on Aspen and copied down my answers without showing any work, you get a second redemption. And you guys will be doing pages 14 to 15 tonight. 14 to 16, excuse me, in your packet tonight. Packet pages 14 to 16. And I will be checking it tomorrow. So some of you guys get a little break. And I'm looking for detail. A lot of work shown out because there was a lot of algebraic stuff we did on last Tuesday. Okay, yes. What's that? Okay, that's true. So now you have the homework for today. Okay, you guys had it off. I'm going to do a second day, so you guys do have it now. So everybody good? 14 to 16 over the break, tonight. And you'll have plenty of time to start it today. Everyone good on the change up? I do not feel comfortable moving on because, again, a lot of people weren't here because they're on the field trip or just out. And I went over about 7 minutes of the stuff we need to do. And this stuff is going to show up on the Regents and on the midterm. So it is important that we discuss it. All right, before we get to finishing Tuesday's notes, in your packet on pages 17 and 18, if you go to your packet, 17 and 18 in your packet, you will see a summary of what we've gone over so far, which will be on your quiz Wednesday. All right, your quiz Wednesday will consist of all the points of concurrency and partitions, which we're going to continue today. All right. Now, on the following page, on page 18, you will see a fresh new summary boxes, which you can fill out on your own, but I wanted you to be aware of what's expected on Wednesday. So what I did right here, I filled in the names of the points of concurrency and how I'm expecting you to find it on Wednesday. So I may give you a triangle on Wednesday's quiz and say, find the circumcenter. Graph triangle ABC, find the circumcenter. I will not and will never ask you to find the incenter on a graph. I will ask you to use your compass to find the incenter. All right, so you guys know how to do at least 2 angle bisectors. You can find the incenter. I'll let you guys do your thing in a second because median centroid's a little different. So at least be able to find the circumcenter on a graph and the incenter using your compass and a straight edge. Okay, for the medians, they intersect at the centroid. Make sure you can find it on a graph. And notice I have algebraic here, meaning, I'll just do it here. And this isn't what should go in your special property, I'm just showing you. Here you go, say that's the centroid, I'll call it C for centroid. And let's say I give you this is 2x minus 4, and this is x minus 6, find the value of x. Those aren't equal to each other. What's the relationship between the two? 2 to 1, right? So 2x minus 4 equals 2 times, in parentheses, x minus 6. All right, so make sure you remember that centroid fact. That's a huge one. And then orthocenter, I could give you a triangle and say locate the orthocenter on a graph. So those are just showing you my expectations for Wednesday, finding the points of concurrency, whether it be on a graph or using your compass and a straight edge. All right. I'm here until 3 o'clock today and then 2:30 tomorrow if you want to come in and review any of these with me. Questions? And then I'm going to ask some partition questions, which we're going to do for a second go around today. Anything from you guys? Questions? Okay. So here's what I want to do now. You guys are going to have to help me out that we're here on Tuesday. Did we do example? We didn't do example 2, correct? I had you guys skip over it for time's sake. Okay, let's do example 2. All right, so I'll give you a second. Go ahead and graph points A and D, connect it. All right, I want you to realize you just didn't graph segment AD. Segment AD has a name, everybody. It has a name. Take a look. A is a vertex on triangle ABC. D is the midpoint of the opposite side. What did you guys just graph here? You didn't graph segment AD. A is a vertice of a triangle drawn to the opposite side's midpoint. What do I have here? This is a median. Yep, that's a median. All right. I guess I'll write it here. And you're trying to locate the point of the centroid. The centroid, guys, will be located hey, that doesn't make any sense that point's P. That's going to be point P. Centroid's got to be located somewhere on a median. Any of the 3 medians, anywhere on it should be the centroid. So what do we know about the centroid? Breaks this median up into ratio of 2 to 1, which means how many equal parts? 3 equal parts. And I'm going to do a better job because I was just crunched with time on Tuesday. So I'm just going to, and I don't want you to do this, I'm just going to eyeball this here. Boom. There you go. I did 3 equal parts. Is that going to be the centroid? No, why not? This point breaks that line segment up into 1 to 2, but I'm looking for what point that breaks it up into? So does everyone agree I'm looking for this point? And I can tell you it's not going to be as easy most of the time when it just lands on a nice point. We're going to find out why exactly that's 3, 0 here now. All right, so I am looking for that point right now. Your help. We do it we do it 2 separate ways. We first do the x coordinate. On the x-axis, as you go from A to D, how many units are you going? And this is where I'm going to turn it over to you guys. How many total units am I going here? Who's got 16? 16? Okay, here we go. From A to D. First of all, where do you start? What x-coordinate do you start at? You start at -3 and you go all the way to where? 6 to point D. Everyone agree? On the x-axis, you go from -3 to 6. How many units is that, Zach? From -3 to 6. You go over how many? 9 total units. You need to cut that 9 units into how many equal parts? 3, right? 2 to 1. So I'm going to take the 9 and divide it up evenly by 3s. Now that tells me every time I go 3 units, I'm breaking it up. Watch, ready? 1, 2, 3. But do I want to stop there? No, because you guys told me you don't want that darn point. You want that one right there. So I got to go an additional 3 for a total of how many? 6. That's why I multiply the 3 by 2. I need to go twice for a total of 6. Now, does that mean I end up on 6 on the x-axis? No. You're 6 units away from where you started. Thanks, Emma. Zach, where did I start again on the x-axis? So from -3, I went over 6 units, and I ended up at 3 on the x-axis. Everyone see how we determine the x-coordinate now? Y-coordinate, same thinking, same procedure. Here we go, y coordinate now. Where do I start and go to on the y-axis now? Here we go, 8, where do I start? 2 on the y-axis, and I go all the way to 1. How many units did I travel? 3 units. And I need to break that 3 up into equal parts of 3. So instead of going 3 units on the x-axis like I did, I'm going to go how many units on the y-axis? 1, but same thinking. Am I just going to go up 1? No, I don't need that point. I'm going to go up how many? 2. And that's where that 2 comes into play again. So you're going to go 2 total units from what point? -2. Up 2, where do I end up at? 0 for a y coordinate. Put the 2 together. Point P is going to be 3, 0. And let me tell you, that point better be on your median. Okay, if you get a point that's down here, something definitely went wrong. The centroid is always located on the median. And 3, 0 is definitely on my line segment. Yes, Bella?
I don't fully understand the last step. Like, what does it mean?
What, this one right here?
Yeah.
Okay. You know you have to go on the y-axis 2 units from where you started to get to that 2 to 1 point. Okay? So I go up 2 units from -2. So if I go up 2 units from -2, I end up at 0. Right? -2 plus the 2 units I need to go.
Oh, okay. I got it.
You sure?
Yes.
Yes, Andrew. Because a median, a centroid breaks the median up into what ratio? Makes it break it up into 2 to 1, which means I need to take that line segment and break it up into 3 congruent parts. If it was 5 to 7, I'd break it up into 12 congruent parts, right? Just so I can count over how many I need. I can count over 2. Okay? Other questions? Yes?
What work do you have to show?
You're looking at it.
Just that.
Yes. Okay, because I can tell you most often than not, it's just you won't be able to just graph it and easily see that it's this point there. All right, it's probably going to be a fraction or a decimal. Other questions? One doesn't make you great, especially you guys that weren't here. Okay, let's keep going. Now, we just did this for the centroid. On Tuesday, I said, hey, I can do any ratio I want. I just told Andrew 5 to 7. I can find any point that breaks it up into a certain ratio. You guys that were here on Tuesday, help me out. We did question 3, all of it? We did? Okay, so let's go to question 4 then. I'm not going to waste you guys that were here. You guys that weren't here, you guys that weren't here, I'll just give you the point. So when I give you the free time in a couple minutes, you guys can try the one out. What was the 1.2? What was example 3 here? The 2 to 3. What do we find? -1, negative 2.4. Okay. Okay, here we go. Example 4. Nobody's done this one yet. 4 to 1. Break this up into a ratio of 4 to 1. So all I did just for visual purposes for you guys, because you guys don't have a graph, for visual purposes, how many equal parts am I breaking AB up into? 5 equal parts. Okay, so visually, ready? That's pretty bad. How about I just try to do this realistically here? Let's see. 1, 2. How about that? 1, 2, 3, 4, 5. Okay, I broke it up into 5 congruent parts. Ready? Do I want that point? No, because that would be a 1 to 4 ratio, correct? Do I want that point? Nope, that would be 2 to 3. Do I want that point? Nope, that's 3 to 2. I want that point right there, 4 to 1. Everyone agrees? All right, that's the point I want right there, 4 to 1. Now, some of you that weren't here are probably thinking, how does he know always to start at A? Because I'd be at a different point if I started from B. Everyone definitely in agreement, right? Here's how. The directions. directed line segment. That tells me when I see directed, you go from the first letter to the second one. A right to B. All right, so if I wanted to go from B to A, I'd write BA instead of AB. All right, so directed line segment A right to B. Grace. I'd say directed line segment BA. Good? Other questions? All right, let's do this. X coordinate. Where are you starting and where are you going on the x-axis from A to B? Where are we going? Where are we starting and going? 19, where are we starting? Okay, I'm talking x-axis though. So I'm starting at where on the x-axis? And going to where? 2, how many total units? 4 units on the x-axis. I need to break up evenly into 5s. And unlike the last one, this isn't pretty. All right, it's a decimal. We got to deal with it. 0.8. So ready? Going 0.8. Do I need to stop? Do I need to stop there? Do I stop there? Nope, going point. How many times am I going to go 0.8 till I get to this point? 4. That's why I'm going to multiply 4 times 0.8. And if some of you are catching on, yes, it's always the first number I multiply by in the ratio, 4. All right, it'll always be that number. And that tells me go how many units? 3.2, but hey, that's not where I end. That's how far I'm going on the x-axis. Where'd you start again? -2, and I'm going 4 units to the right towards 2. Sorry. There we go. Plus 3.2. Where do you end up on the x-axis? 1.2. Any questions? Hey, ask now because I threw a little trick in for the y coordinate. I don't know if anybody sees it yet, but I threw a little trick in this one. Okay, here we go, y coordinate. I'm going from 5 to how far are you going? 2 units? From 5 to -3? 5 to -3. 8 units? Everyone, we're going 8? Yes? Okay. Got to divide that 8 up into 5s, right? What was that, 1.6? Yeah, 1.6. I do this too many times, I forget. 1.6. What are you doing with that 1.6? Because that, from here to here is 1.6 on the y. I got to get down here. So 1.6 just isn't going to cut it. 1.6 times 4, yep. And that'll end up being 6 point. Here's the curveball. You're like, oh, I started at 5, right? And add 6.4, I got it, 11.4. Hey, 11.4 is up here. Not even close to your line segment. Notice where we were going. 5 to -3. We were going down on the y-axis, weren't we? So I don't want to add 6.4. What do I want to do? Subtract it. Have to watch out for that. So you end up at -1.4. Does everyone see why I subtracted versus add like I've been doing? So your coordinate is going to be 1.2 comma -1.4. Now, how many of you are the wheels are spinning and you are saying to yourself right now, well, so I don't mess up, why don't I just say -8 up here? 5 to -3, I'm going down 8. That's fine. If you watch, ready? If you went -8, this becomes a -1.6, and this becomes a -6.4, you're all set. Okay, so if you want to avoid that risk of forgetting to subtract, you add and maybe not subtract, Just make it negative at the beginning instead. That's fine. Yes, Maddie?
Why do you multiply it by 4?
Because, ready? 1.6, if I go down 1.6, it's only going to get me to that point. If I go down 1.6 again, it's going to get me to that point. If I go down 1.6 again, it's going to get me to that point. Another 1.6, I'll be finally there. I go down 4 times.
Okay, but what if you don't have a graph?
We don't need one because you know you're going to that 4 to 1. So you got to go over 4 every time. You're breaking it up into 5 congruent parts, right? So you need to get to that 4th point. Like if I go 2 to 7, that's 9 congruent parts. I got to get to that 2nd point. So whatever my distance is, I'm always multiplying by 2. Right? Here you go. If I go 3 to 5, I know I'm breaking it up into 8 parts, but whatever distance I find out originally, I got to go 3 times. Okay? Or if I'm going backwards, if I go from this point up, I'll go 5 instead. Depends where I start.
So you always multiply the y coordinate by 1?
X and Y.
Okay.
X and Y. Don't treat this as X and Y. I multiplied both of them by 4. Multiplied that one by 4, multiplied that one by 4.
Okay.
That gets multiplied by the same thing every time. Other questions? These are good questions you guys are asking today. Okay, training wheels off. Let me see you do the next number 5 on your own. When you think you have it, call me over. I'll check you, and then you can go on to number 6.